Good afternoon. My name is Thomas Turca. I am the co-founder of Omicure, and I have the chance to be with Professor Pierre Santini, who is head of translational development at the Centre Léon Bérard in Lyon. Today, we will present some partnership work we are doing together for several years. I will start by a few words on the tech we are using, and then we will present into more detail one of the projects. No, c'est pas nous. Okay. So first of all, big surprise, we are using AI. But unlike most of the AI you will see here today, we are not into learning into huge data set, and we are not into deep learning. We use an explainable AI based on formal concept analysis. The main idea is that we identify strong relation between variables from data sets that can be very small, from 5 to 6 patients, but also 2,000 patients. The data set can be also heterogeneous and can be incomplete. I will try in a 30 seconds to tell you a little bit more about formal concept analysis. The main idea is after you have gathered the data and you have made ensure that they are accessible and queryable, then the idea is to identify all relations between variables and to rank them, and finally to be able to interpret and to highlight the best ones. We can make an analogy with a book collection. When you start from an unorganized and disorganized and uncategorized book data set, you can first organize it by author, then you will rank by date, and eventually I can choose to highlight at a high level my favorite one. On a mathematical point of view, it's what mathematicians would call matrix diagonalizations. And if you have more questions about that, we may talk later about that, but it's quite complex. We are working with Centre Léon Bérard for several years now. We mostly do retrospective analysis on RNA dataset from clinical trials, trying to identify biomarkers, transcriptomic biomarkers. And I will give the floor to Pierre, who will give a little more detail about one of the projects. C'est le bouton vert.
Okay, thank you very much, Thomas. So I should remember that this is the green one. So the medical context are patients with cancer, advanced cancer, and patients who have been treated already by different therapies, and they become resistant to common therapies. And so the reason why we try to screen them for some molecular alterations is to drive them to new therapies, innovative therapies. And so one of the main issues we have with those patients is that sometimes they are tired, and their prognosis can be different, but it's very different. It's difficult for us to define the ones who have poor, very poor prognosis, and those who have a better prognosis. So in the routine care, in some of our screening programs, we run RNA sequencing, which is gene expression profiling of the tumor from the patient. And the idea is to use the information we actually don't use in the routine care to identify those patients with either a good prognosis or a poor prognosis. So this is what we did from a population of patients included in the Profiler trial. It's a trial that is sponsored by Centre Léon Bérard in Lyon. And a subset of those patients, almost 250, had this gene expression profiling data available. So we provided the data to Omicure, and they used their CHEM AI platform using this formal concept analysis mathematical concept, to identify few transcripts. And what I liked in this project is that their goal is really to identify a very short list of genes, not a very long list, which is often very hard to reproduce in other patients. So this is what they did. So we provided the data. The data was consolidated in their platforms, and we mostly used for now gene expression profiling, which is data from 19,000 genes for which we have RNA expression levels available. So this is the description of these gene expression profilers of the CHEM platform. And the endpoint we used was survival analysis. So we wanted to to identify models that were able to predict overall survival. And so it goes, from a very large amount of relations to a smaller amount of models, and then we select the 100 more accurate models, and we ended with one model including 4 genes. And so one of the particularity of this approach Omicure is developing is that they select genes that we may actually transform to using other technologies. So basically, it ends up with 4 genes. So you see two of them needs to be high, or 2 other can be high, and this allows to predict survival better than what we were able to do using, clinical information from the patients. So you have here some of the data, the performance of the model that they were using. So of course, this needs to be tested. This model and others that we are working on in different contexts, for example, the context of immunotherapy, need to be validated in other data sets to make sure that they are working well. And hopefully this can be translated to a test in which we would just look at these 4 genes using a technology that is much simpler to implement in the routine care. And we've presented this work at the European Medical Oncology meeting at ESMO a few weeks ago. And I think it's done. So we are happy to take any question.
Any question?
Yes?
No. Yeah.
Yeah, or
Probably.
maybe come here. Yes. Sorry.
Yeah, thank you for the presentation. Like about the gene that you founded, is there any relationship between the gene, or it is individually interesting on their self, or is there any weight or in their combination for this expression?
So there is no weight. I'm not a data scientist. I'm not sure Thomas is either a data scientist, maybe more than myself. But what I understood is that there is no weight, which is an advantage. So that's one thing. So we are not doing here biology. In other projects, we are interested in the biology. Here, the idea is not really to find genes that might be biologically important in tumor growth, that may be important targets. Here, it's really to use this information to say, well, this patient will have a prolonged survival. It is worth maybe trying innovative treatments and proposing him those treatments and get him into clinical trials. Or, this patient has, unfortunately, a poor prognosis, too bad to really be able to perform well under a clinical trial. So it's a way to stratify patients.
Okay, thank you very much.
Does it answer? Okay.
Thank you very much.
Merci. Okay.